it is very common to want to fit a straight line to some data. So let's imagine you have some data points, x and y. The data points might look like this, with various error bars. And you want to work out what's the best line that goes through them, which might look something like this. Now a straight line will be an equation of the form y equals ax plus b. Now a here is the gradient, so that's telling the ratio of the height over the length, how fast the line goes up, and b is the intercept, which tells you how far above or below 0 it crosses x equals 0. Now there are many ways to fit this. You can do it by eye, play around with it, draw it with a ruler. If the error bars are the same on every point, then you can actually do it in Excel. But if you've got uncertainties which vary from point to point, Excel won't do it for you. Luckily there are Python libraries that do this. Now I've written a Python program, LineFit here, which will do this. It's got full instructions inside the program. It uses the stats model library that someone else wrote for me. You need to get your data in a spreadsheet, data something like this, with the x values, the y values, and the uncertainties, and you want labels in the first column telling what the things are, x, y, and error, or whatever they might be. Then you save this, save as a comma-separated variable file, a .csv. Then in your program, you put the name of that file in here and run it. It'll read in the data, plot it with error bars, and then it will do a weighted fit. So it'll go with the best fit, but taking the error bars into account. So it pays a lot of attention to the points like these ones with small error bars, and doesn't pay anything like as much attention to these points with the large error bars. It'll output the intercept and the gradient, and the errors on both.